All right, and number 10, somewhere in the margin, make sure you put 25 drops because it's going to say do it again. It's going to say repeat. We don't want to use 50 for number 10. We want to use 25 with ammonia, 50 with lemon juice. So that's correct. 6 should be 50, 10 should be 25. Obviously, if you're at home, this isn't going to make a difference for you guys. Has everybody got that change? The other, where it says conclusions, you do not have to do those. Those are just going to guide your thinking as we get into the lab report. I mean, you can certainly answer those on the back for your own purpose or your own use. This will not be part of the lab report. This won't be part of it, okay? Anybody have any questions there? All right, you're gonna do two things. And I'm gonna show it to you real quick. You should be able to get one part done today, the other part done the next one, then we're gonna write a lab report, and then it's gonna be due, and we're starting bones. That fast.
Really?
Yeah, I know, I'm excited too. She's excited as well. We're both anatomy people. So over here, let me review what we have on the counter. Pay attention. These ones right here, the square ones that are not marked, that is water, okay? The white one is milk. Now, we were supposed to use skim milk, but all they had downstairs was 1%. I don't know what's gonna happen, but we'll see what happens and take a look at it. It should still work, but taking the fat out using skim milk was important. Well, I don't know what's gonna happen, but that's 1%, not skim, when you're writing your lab reports. These little guys right here, if they're the cylinder ones and they have labels, ignore the labels. They are all ammonia. And see, water in those ones, ammonia in these ones, and that's important because the water and the ammonia physically look what? Everybody got it? I do not want to see anybody going, I wonder if this is ammonia, and taking a deep breath right out of the top of the bottle. That's smelling salts, and you might actually fall down. Not guaranteed, but some of you could pass out and hit the corner of the table. That's no bueno. That's no good. Okay. If you did have to smell it and you wanted to test the theory that that's really ammonia, what are you supposed to do in chemistry class? Be a wafter. Yeah. And if you're like, ooh. Okay. So that's ammonia. Now, because I'm an idiot, I'm admitting that on camera. Because I'm an idiot, I got 2 bottles of lemon juice out of my fridge this morning without my wife knowing, only to find out that one of them was lime. So what I have here, the front 3 are lemon juice, which goes with the lab, and the back 3, and you can see there's a little pulp at the top, so you just shake it up. That's lime juice. And Ms. Swartz looked it up for me this morning. This is more acidic than this. So whichever one you take, can everybody see the difference in those 2 colors right there? Lime, lemon. Make sure you make a note of that on your paper so that when you're doing your lab reports, because this will probably make it go faster. This will be a little slower. Okay? Up to you guys though. And if you forget, I will remember the colors. So this is a real scientific lab. I have the wrong milk and the wrong juice. Way to go. Great teacher there. Still getting paid. Joke's on. No, I'm just kidding. Okay? These are beakers. I'll let that sink in. Okay. These are little baby test tubes. Okay, you're gonna need one of those. This is a stirring rod. Ooh. This is made out of glass, please. No Harry Potters in here, okay? None of that. Okay. Now what are you gonna do? Oh, wait, yeah. This is pH paper. Why is that not out? Okay, this is the expensive stuff. Can you please not, like this little box right here is about $50.
Oh my God.
Yeah, can we not waste this? This is like the good stuff I use in my taxidermy shop, like swimming pools, like the really good stuff. I used to use the stuff out of China, but it didn't work very well. That is not a bust on China. I'm just saying the paper wasn't very good. Okay? So we have these little guys, and then you can see you can just do that. All right. Step 1, you have to have baselines, and that will be your first graph. So you're going to take a paper towel. Hopefully you guys can see that on camera. Paper towel, and then you're going to test the pH of water, milk, ammonia, lemon juice. That tells you where you're starting, or lime juice. That tells you where you're starting. That'll be the first graph. First physical thing you have to do, okay? You're going to take milk, and there's one for each table. You'll have to share it, okay? I'm going to put 50 drops of milk in the test tube. I'm then going to take my stirring rod. Here's the interesting thing about water-based molecules, or water-based liquids. If I pull that out, what will happen? There'll be one drop sitting on the end of there. And if you don't go like that, it'll stay there. So you can have a piece of pH paper, drag it across the paper, and when should you read the pH paper? Immediately. Because if you don't, it'll start to oxidize and change the color or the reading. Read it immediately, like within half a second or a second. Everybody with me? So you got the milk in there. You're like, hey, Scarbs, I already tested the milk. Yeah, you didn't test it in here. There could be contaminants. We want to make sure that this is pure science. Test that, and then it's going to say, add 1 drop of lemon juice. So I'm going to add 1 drop, and then I'm going to stir. Everybody hear that sound? Please do not go bang, bang, bang. What will happen?
Shatter.
Yeah, this is coming right out the bottom, and then glass and lemon juice milk is going to be all over you. It's not good, okay? You're going to get 1 drop on there, and you're going to record the pH. So somebody in your group, you'll do the trowel, milk plus lemon juice. You'll do baseline of milk, pH, and then you'll put drop 1, pH, drop 2, pH, drop 3, pH, doing the same thing every time. Add a drop, then what? Stir, read. Add a drop, stir, read. Now after every drop, you should be looking in the test tube. Hold it up to the light. You are looking for a noticeable change. And it's gonna, does everybody remember titrations from, did you guys do titrations in chemistry?
Yeah.
With phenylalanine, the color change, it changes instantly, and sometimes you put too many drops, you're like, oh, and you gotta start over. It'll be like that. Does everybody know what I'm talking about, titrations?
Yeah.
If you had chemistry, you should know what I'm talking
I
about.
remember it, and it was like.
Yeah, you had the solution and you turned a little valve and 1 drop would go at a time and you stirred. No? Okay.
Hey, maybe he didn't like you guys.
I am actually going to go down there and talk to him, and he's going to be really furious with all of you, and I'm naming names.
Don't name me.
And that's on YouTube, okay? I will. Landed. Done. All right, so you are looking for a noticeable change. So let's say I get to drop 7 or 8, and you're like, whoa, that doesn't look like milk anymore. You would put next to that, drop 8 pH change. Make sure you highlight it. And then you have to do the scientific overrun. We want to go another 8 to 10, 8 to 12 drops to make sure that there's no significant change after that. Everybody with me? Don't hit the change and stop, because all of your reports will be wrong and you're going to get hammered. Okay? Make sure that once you see the change, you move on another 8, 10, 12 drops beyond that. Keep reporting so that you have a nice little chart of data that we can make into a graph or table. Does everybody understand? The lemon juice one is going to be 100% obvious if you're what? Paying attention. So don't jack around. All right, that's the first trial. Now what you have to do is then you have to clean that out. So you'll have to come over to one of the sinks. You might even have to scrape down the sides, get it nice and clean, everything out of there. And then you guys know about surface tension, right? Some water's going to stick in the bottom. Everybody watching this, you would do this in this sink, but I would have been off camera. Don't do it on the floor. Do it in the sink. You want to hold it nice and firm and snap, snap, snap. And then that'll dislodge the water from inside. Then we're going to start over. Trial 2, 25 drops of milk. Do a baseline test. And then we're going to trade out lemon juice for ammonia. We're going to add 1 drop of ammonia, pH. Drop 2, pH. Drop 3, pH. Drop 4, pH. And then we're going to record when there is a noticeable change. This one is a little bit more difficult to see, but if you pay attention, you will notice it. Once you notice the change, what do you do after that?
Keep going.
You do another 8, 10, or 12 drops to make sure that there's no additional change. That's just good science. It's called the overrun. Anybody have any questions? When you're done with that, you have to clean this out, make sure it's nice and clean. We don't put anything dirty back in there. We make sure our stirring rods are wiped off nice and clean, and they go back here. And what should my lab look like when you're done?
How we found it.
How you found it. Anybody have any questions? I'm not telling you what you're actually looking at until we get to the explanation so that there's at least some, oh, that's pretty cool. pH lab. If there aren't any questions, listen, here's what I do today. Half of you are doing milk and ammonia, half of you are doing milk and lemon juice, and then the next time we'll switch and do the other one. So coordinate that amongst yourselves. You cannot all do the same one. I don't have enough stuff. Ready? Ready? Set? Go.